Hello students, how are you? Hope you will be fine and doing great in your life. In this today's video lecture, we will see Avogadro's law for the gases. We will see what the statement says and how to do questions based on it. Okay, well, my name is Vivek and you are watching Apni coaching classes. Let's start the video. See, what the statement is, at constant temperature and pressure, gases contain equal number of moles at equal volume. Means, suppose you are having two containers. First of all, see the statement. Suppose you are having, sir, two containers. Likewise, this is A and this is B. Okay, two different containers. Suppose in this there is gas A and in this there is gas B. I'm writing it with another color. This is gas B. If volume of the containers are equal, see, if volume of A is equals to volume of B, therefore number of moles of gases in A means number of moles of gas A will be definitely equals to number of gas in the B. You are saying that if volume are equal, then number of moles will be also equal. Or you can say, sir, PV equals to nRT from the ideal gas equation. If you put temperature and pressure constant, temperature, this term, I'm writing it with different color so that you can relate it. Temperature and pressure is constant. So see, these both are the constant number. Also for a fixed mole of gas, we are saying that volume, R is also a constant. R is also a constant. So see, volume is directly proportional to number of moles. Volume will be directly proportional to number of moles in this case. That this law only explains that for a at constant temperature and pressure, volume will be directly proportional to number of moles for a gas. Okay, it means we can write it as V1 will be directly proportional to number of moles of 1. V2 will be directly proportional to number of moles 2. When we will divide it, we will get V1 over V2, V1 over V2 exactly equals to, sir, N1 over N2. V1 over V2 will be equals to exactly equals to N1 over N2. This is how you are going to solve the questions. This formula will be used. Okay, write this all. I'm going to give you a simple question based on this law. Okay, hopefully you have been written all these things. Let's see a simple question based on it. Suppose reaction is taking place like N2 plus 3H2 gives 2NH3. Actually, this is a reversible reaction, so I will write it as like this. Suppose you are having 3 liters of a container in which reactants are put. Means suppose you are having container of 3 liters. Container is of 3 liters in which reactant is put, and after reaction product will form. After the reaction product will form. You are having 3 moles of nitrogen and 2 moles of hydrogen. You have to find how many moles of ammonia will produce. You have to calculate how many moles of ammonia will be produced. So how we are going to proceed this question? See this. We'll use our law which says that volume will be directly proportional to number of moles. What it says that, sir, volume is directly proportional to number of moles. Okay. When 3 moles of nitrogen combine with 2 moles of hydrogen, see, this is not a question which will use V directly proportional to N, because this is so much simple question. We will just use stoichiometry to give the resultant answer. See, you are having 3 moles of it and 2 moles of hydrogen, and how much product is formed you have to calculate. Okay, let's solve it. How we will going to solve it? See, for 1 mole of nitrogen, it will require 3 moles of hydrogen. 1 mole of nitrogen will require 3 moles, means much more hydrogen is required. But see, you are having 3 moles, so 3 moles of nitrogen will require, sir, 3 threes are 9. It means it requires 9 moles. But how many moles of hydrogen it is? 2 moles. It means, sir, hydrogen is the limiting reagent. Hydrogen is the limiting reagent. And see, little dear, limiting reagent will only decide how much product we are getting. Limiting reagent, GENT. So how much moles you are having of limiting reagent? 2 moles. From seeing the stoichiometry, so 3 moles will make 3 moles of hydrogen will make 2 moles of NH3 ammonia. So sir, if you are having 2 moles only, so it will form 2 over 3 multiplied by 2, this much moles of ammonia you will get. This is not the question of V directly proportional to N, because I have to first of all tell you what is the limiting reagent. After that we will mix this question with this law. Okay, now you are able to get the how you will dealing that which is the limiting reagent among the reactant, and after getting the limiting reagent you will decide how much product will be formed. Now I am giving you a question which will be definitely based on it. Okay, see what is the question. Suppose you have initially 2 liters of oxygen gas and number of moles are 2 liters of oxygen gas and 2 liters of oxygen gas. See, I'm writing a question different. Suppose you have initially 8 gram of oxygen gas in 2 liter of container. If uh, if you add 8 gram more to the container, how much extra volume should be increased of container so that internal energy of the resultant mixture becomes same as initially. See, this is a question. I've created a big question, but answer will be just in the few steps. If you will read all the question, you will get that initially, sir, there are 8 gram of oxygen in the container of 2 liters. Now we have added 8 gram more, and this question is asking how much volume should be increased so that the kinetic energy becomes same, or you can say internal energy or the molecule becomes same. So how we are going to see this do this question. See how many moles of gas you are having initially. So number of moles is equals to mass over molecular mass. Mass is this, and molecular mass for oxygen gas it is 32. It means 1 over 5, which will be 0.25 moles we are having, and initial volume is, sir, 2 liters. Final number of moles, sir, finally 8 gram is more added to it. So sir, final number of moles, and final I am writing it, and initial it will be 16 over 32, which will be, sir, 1 over 2, it will be 0.5 mole. It means, sir, just twice you have increased, just twice. Also, sir, volume is directly proportional to number of moles. Volume is directly proportional to number of moles if we do not change with pressure and temperature. And in this question, neither pressure, no, neither either what I'm saying, neither pressure nor temperature is changed, so we can use this law, which is Avogadro's law. So if number of moles become twice, so volume will also become twice. So as to consider, or so as to just make the internal energy constant. Volume we will increase, so internal energy become constant. If we will not increase the volume, suppose in 2 liters only we are adding more gas, so there will be more randomness, more internal energy, means that internal energy will get increased. And that questions will do with thermodynamics principle, where we will see how to calculate internal energy. But in this question, internal energy is not changed. It means we have to use Avogadro law so that we can find the volume, final volume. So V final will be, sir, just 2 times of the initial, which is 4 liters. See how simple is the question. How simple is the question by using this law. So always remember these laws. In the previous video, we have discussed Boyle's law, then Charles' law, then Avogadro's law. Okay, in the next video, we will see some more concept related to it. Till then, Jai Hind to everyone.